Anusha, you can begin.
Good morning, respected judges, participants, and my fellow ISCians. Born from the minds of the undergraduate community at ISC Bangalore, Pravega is an idea that grew into an intoxicating 4-day experience. Barely 7 years old, but having gained enough momentum since its inception, it has now claimed a spot on the list of top 10 fests in India. Owing its popularity to its racemic blend of science, art, and culture, and its history of hosting a myriad of competitions, expert workshops, and electrifying performances from top artists, Indian and international, this is the site of a footfall of thousands, a fest that is undeniably growing bigger by the year. Kamenigma is Pravega's flagship chemistry event. It was started in Pravega 2020 and was a massive success in its first year itself, with teams from all over India visiting IISc to perform intriguing original experiments designed by the undergrads of IISc and presenting their findings to a panel of distinguished professors in true scientific thesis defense fashion. Owing to the devastating COVID 19 pandemic, this year the event is being held in an online mode. We have tried our very best to not let the lack of in person interactive sessions affect the experience. Students excelling in chemistry from all over the country are here with us today to prove their mettle once again. We also have a star studded panel of judges comprising of eminent chemists from various fields. Team Kamenigma sincerely hopes everyone has fun today and that everyone goes out of this competition knowing a little more chemistry than they started out with.
Thank you, Anusha. I will now name the finalists of the event. In Team A, we have Orpun Basu and Aditya Sakrikar from IIT Bombay. They are first year UGs. From Team B, we have Ankun Nath and Ritik Haldar from IISER Pune and they are second year UGs. In Team C, we have Pravar Kataria and Dev Gupta from Pragati Public School, Delhi, and they have completed their class 12. In Team D, we have Kumar Satyam and Hardik Rajpal from IIT Bombay, and they are UG first years. Kumar Satyam, unfortunately, will be unable to attend this final owing to a family medical emergency. Our best wishes and condolences are with him. In Team E, we have Shayantun Khan and Shubhaji Chakraborty from IISER Kolkata, and they have completed their first year of study in an undergraduate program. In Team F, we have Shomodipta Bishash and Shagoto Shaha from IACS, and they've completed the second year of UG. This is the rough timeline of the event. At 9 a.m. right now, we are starting out. At 9:20, the first round, the objective round on the spot will begin. At 11 a.m., we will release the subjective questions and we shall break, and the participants shall be solving the subjective questions. At 1:15 p.m., there will be a presentation round for these subjective questions, which shall end at 3:15 when we shall recess for lunch. We shall reconvene at 3:45 p.m. to have the round 3 of the analysis design round, and it will be a presentation round. We expect this to be over by 6:15, at which we will declare the result and have the vote of thanks. Please keep in mind that this is an online competition and logistics may have some difficulties. So a gap of maybe 1 hour is to be expected, and we expect the event to definitely be over by 7:15 or 7:30. The first round is on the spot, and as I said, it shall start at 9:20 and is expected to be over by 11. Participants will have to answer conceptual questions within a stipulated time span in this. There will be 6 easier questions, one per team, worth 10 points to be answered within a time span of 4 plus 1 minutes, and 6 challenging questions, one per team, worth 15 points each to be answered within a time span of 6 plus 1 minutes. The time in brackets signifies an extended time, which, if utilized, will result in a penalty of 10% of the obtained score. You will be informed about the completion of half the time, the full time, and then the penalty time as well. So, for the easier questions, you will be informed at 2 minutes, 4 minutes, and 5 minutes. following which you will not be able to go on. For some challenging questions, a hint is available which may be utilized with a 20% reduction in the obtained score. Under no circumstances will going past the allocated time, including the brackets, be allowed. We shall release the questions of the subjective round at 11 a.m. Teams may choose to attempt and solve any number of questions and upload a PPT or a doc file or a PDF file. We are not stringent here about the mode of the presentation or the aesthetics of the presentation, but rather on the content of the presentation. So you can upload these by 1:15 p.m. and no submissions past 1:15 p.m. will be accepted. And no edits made to the document after 1:15 p.m. when the presentation round begins may be allowed. And if please do not make these edits because this shall be monitored by a dedicated team and any such attempt will be met with strict penalties, not excluding disqualification. Presentation round shall begin at 1:15 p.m. and is expected to be over after 2 hours, that is at 3:15 p.m. Each team shall present the solutions to the panel of judges for a maximum duration of 12 minutes. Again, you will be informed about the times and I shall get into the details of that at the beginning of this round. This presentation will be followed by questions from the panel of judges for a total duration of 8 minutes. During the presentation round, no changes to the submitted presentation may be made. We shall recess at 3:15 for lunch for a duration of 30 minutes and we shall reconvene after lunch at 3:45 for the design analysis round. The questions for this round have been released at 9 a.m. on the previous day, that is yesterday on the 30th of July. The questions for this round are either problem 1A or 1B. Either one of them must be attempted and they're worth 75 points. Problem 2 is not non-negotiable and they must be attended. And problem 3A or 3B must be attended, either one of them. And the participants must present the solutions to the above problems mandatorily as a presentation. The teams must submit the final presentation by 12 noon today, and no edits after that shall be allowed. This presentation round begins at 3:45 and is expected to be over in 2.5 hours by 6:15 p.m. And they must similarly, as in the subjective round, present the solutions for a duration of 15 minutes followed by 10 minutes of questioning. And here are our judges for the event today. Anisha, please go.
Yeah. Dr. Shantanu Mukherjee is an associate professor in the Department of Organic Chemistry at the Indian Institute of Science. He completed his PhD at the University of Cologne, Germany, under Professor Albrecht Bergesell. He then went on to do his postdoctoral research first at the Max Planck Institute, Germany, under Professor Benjamin List, and then at Harvard University under Professor E.J. Corey. He was awarded the INSA Medal for Young Scientist in 2014. He became a Fellow of the Royal Society of Chemistry in 2018. He was on the editorial board of the Journal of Organic Chemistry from 2018 to 2020, and since 2019, he has been the associate editor of the Journal of Organic and Biomolecular Chemistry. His primary research interests revolve around various aspects of enantioselective catalysis, with particular emphasis on the development of new catalytic enantioselective transformations. Dr. Debashish Das is an assistant professor in the Inorganic and Physical Chemistry Department at the Indian Institute of Science, Bangalore. He completed his master's and PhD from the University of Michigan, following which he did a postdoc at Massachusetts Institute of Technology with Professor Barbara Imperioli. He was the recipient of the Excellence in Research Award from the Department of Chemistry in the University of Michigan. His research interests span a variety of fields like chemical biology, protein engineering, membrane biology, and enzymology. His research group is involved in interdisciplinary research involving the applications of metalloenzymes in biosynthetic pathways and the bioremedification of toxic chemicals. Dr. Garima Jindal is an assistant professor in the Department of Organic Chemistry at the Indian Institute of Science, Bangalore. She completed her PhD from IIT Bombay and did a postdoctoral fellowship at the University of Southern California with Nobel laureate Arya Bershel. Dr. Jindal won the Eli Lilly Outstanding Thesis Award in 2015. She currently heads the Computational Chemistry and Biochemistry group at IISc, which has an interdisciplinary approach towards understanding enzymatic systems using computational methods. Her research also aims at improving on current methods of protein synthesis using directed evolution. Dr. Nagafani Athukuri is an assistant professor in the Solid State and Structural Chemistry Unit, Indian Institute of Science. He completed his PhD from Stanford University and did his postdoctoral research at IBM Research Almaden. In March 2014, he received the Invention Achievement Award from the IBM Corporation. His research focuses on developing novel materials and devices for energy-efficient electronics and energy storage with particular emphasis on high-energy density batteries.
Thank you, Anisha, for the introduction of the judges. So we still have time, and if everyone is already present, then we can start off with the objective round. Shukri, please let me know if everyone is already present.
I'll just check the list of participants once. Yeah. There are 10 participants, Anubhav. How many do you expect?
11.
10, 11. Yeah, it's fine then. There are 10 participants here.
Okay. In total, I expect 12, but one will not.
Okay. Inclusive of that 11. Then someone is not here. Let me just track. Could you guys please unmute and tell if your teammates are here or not? Anyone whose teammate is not here? Participants?
Yes, sir. My teammate is here.
Okay, cool. So I'll just go team by team. Just a second. Orapon Boshu, Aditya Sakrikar. Both of you are here?
Yeah,
Yes, I can see. Cool. Ankon and Ritik. Both of you are here. Cool.
Yes.
Pravar and Dev. Are both of you here?
Yes.
Both of you are here, right? So, which one is Dev's?
Dr. Sonali Gupta.
Okay, cool. Then Kumar Satyam and Hardik Rajpal. So here, one of them will not be joining. The other one, Hardik, is here.
Yes.
Cool. Sayantan and Shubhojit, both of you are here.
Yeah, we are here.
Yes, we are here.
Okay. And Shomadipta and Shagato, both of you are here.
Yes.
Just a second, I cannot see. Shagato, I can see. Shomadipta, which one is your account? Both of you are
I'm here. Both of you absent.
Yeah, okay, Shomadipta. Okay, I don't know why it was not showing up. Oh, you have not been made an attendee. Just a second. Yeah, so Anubhav, everyone is here. I think we can start now.
Okay. So this is the objective round on the spot for this event, and it was stipulated to start at 9:20, but since we are done with the introduction, we shall start now, and it's expected to be over by 11 a.m. And like I said, there will be 6 easier questions, one per team, with 10 points to be answered within a time span of 4 plus 1 minutes. After Shukriya finishes reading the question, the timer shall be started, and at 2 minutes, at 4 minutes, and at 5 minutes, you will be informed about the time. Please keep in mind that if you utilize the time within the brackets, you will be penalized 10% of your obtained score. There will be 6 challenging questions following that, one per team, and we shall go in alphabetical order. That is team A followed by B, then C, D, E, and F. And these challenging questions will each be worth 15 points and will have to be answered within a time span of 6 minutes and 1 additional minute, which will result in penalization of 10% of the obtained score. For some of these challenging questions, a hint is available that will be demarcated by a large question mark in the slide. And should you choose to utilize that hint, you will be met with 20% reduction in the obtained score. Under no circumstances shall we allow going past the allocated time. So first we shall go with team A. Shukriya, are you ready?
Yeah, I'm ready. And also, Anvesha, you're keeping track of whether they're using the extra time and the hint, right?
Yeah. I'm
Cool.
keeping track of all of them.
Yeah, thank you.
Then we shall
Also,
begin.
I will not be announcing the start of time. As soon as Shukriya stops saying the question, you can start thinking about it, okay?
Yeah. I'll just mention at the end. Your time starts now.
Teams, please be ready. We are starting.
So here's my question to Team A. Team A is Orpon and Aditya.
Yes, sir.
So consider the following phase diagram of a substance X. There are 4 options given to you. Which of these are correct? Density of X increases on melting at its normal melting point. 2 mu of solid is equal to mu of liquid plus mu of gas at the triple point. Sublimation of solid X is observed if you apply 10 kilopascal pressure at 150 Kelvin. X in liquid phase has the lowest chemical potential at 250 Kelvin and 11.3 MPa compared to solid or gas phase. Your time starts now.
Two minutes.
Hello.
Yeah, please go ahead.
Option B, B for Bombay.
Justification for your answer?
The justification is partially because of its correctness and partially because of the wrongness of other options. So you see, option C is wrong because that point which is asked for does not lie within the within any equilibrium line. It is just a random point. Then option D is also not the point of any minima, and finally for option A also we can see that the density of X will not increase on melting. So option B is correct.
Okay. Thank you for your answer. So Anubhav, we should move to the next question. So this is my question to Team B. Team B is the team comprising Onkon and Ritik. So my question to you guys is, you've been shown two compounds on the screen. Why are the above compounds stereogenic, and explain which of the above compounds will undergo faster racemization? Your time starts now.
Okay.
Two minutes.
Hi, we are ready with the answer, I think.
Please go ahead with your answer.
Oh, yes. So, our hypothesis is that the above compound is stereogenic because of a ring flip that can occur within the cyclohexane for the cyclohexane ring. So, upon flipping, one of the CH3 bonds could come above the plane, the other, the CH3 bonds would be above and below the plane. Upon ring flipping, the CH3 that is above the plane would come below the plane and vice versa for the other. So for this ring flipping to occur, just one thing. So this ring flipping occurs in both these molecules. That's why both of these are stereogenic. But for the ring flipping to occur, the single bond character, I believe, would be would need to be greater for a greater ease of this ring flip. Because in double bonds, due to the pp overlap, this would be difficult. So in CH3, since the CH bonds are less strong than that of CD, the hyperconjugation would result in a greater single bond character at the double bonds, which are a part of the cyclohexane, the middle cyclohexane ring. So that is why in CH3, since the single bond characteristic is more in for those double bonds, the ring flip would be easier. While for CD3, since the double bond characteristic is more, the ring flip would not be as favorable. So that's why the CH3 compound would undergo faster racemization. That's an answer.
Okay, thank you for the answer. So I think we can move over to the next question now. Anubhav, next question, please. So this is the question to Team C. Team C is Pravar Kataria and Dev Gupta. So a transition metal oxide, TO, has a rutile-like structure where T is octahedrally coordinated by O. It undergoes a solid-solid electronic phase transition at a certain d orbital occupancy. The temperature of transition is directly correlated with the d orbital occupancy. The TO octahedra are tetragonally distorted, with the orbitals oriented with respect to the crystal axes x, y, and z. Assume that the d orbital of relevance is dx squared minus y squared, and the crystal is compressed along the z-axis. What would happen to the phase transition temperature? Rationalize your answer. Your time starts now. Also, just for the information of the judges, we have a judges channel in the team for communication between the judges and with the organizing committee. So we'll request the judges to please check the channel as well.
We would like a hint in this question.
There's no hint available in this question. Those are for the difficult questions, so you'll get some more time to answer as well.
Oh, okay.
Two minutes.
Yes, I think we will answer.
Please go ahead with your answer.
We are assuming that the compression is due to the Giant-Taylor distortion or Giant-Taylor compression, and it is compressed because it is more electronically repelled by the incoming ligands, which is also correlated to higher occupancy of d orbitals because those might be the stronger ligands with higher electronic density. So it is mentioned that the temperature of transition is directly correlated with d orbital occupancy. So higher the occupancy, higher the temperature. So we would like to claim that the phase transition temperature would increase due to the compression.
Okay. So thanks for your answer. We'll now move over to the next question. Anubhav, next question, please. So here is I hope you can see the question clearly. So it's a single reaction where A is reacted with sodium hydride and ethanol, and you get this product. Now, this question has two subparts. First of all, you have to identify what is A. There are 4 substrates given to you. And further explain why, on adding excess of ethanol, the amount of product in the reaction mixture is significantly reduced. Your time starts now.
Two minutes.
Yes, I think I'm ready with my answer. So I think just to be sure, I am Team D, right?
I didn't get your. What did you say?
I'm the guy who the question is directed to, right?
Yeah.
Right.
Wait, just a second. This was directed to Team D. Yes.
Okay. So I think the best option for A would be option 3. There's only one product possibility with that, excluding stereoisomers. And yeah, I think on adding excess of ethanol, the carbanion formed intermediate goes back to the substrate. So because ethanol acts as a protonating agent. So yeah, I think that's it.
Okay. Thanks. So now we'll move over to the next team, Team E. So this is the team of Shayantan Khan and Shubhajit Chakraborty. On your screen, you can see a Bornyl cation. Now, in the above Bornyl cation, do you expect any deviation in the C1, C2, H2? There have been 4 atoms which have been marked. We are referring to the C1, C2, H2 bond angle as compared to the typical tetrahedral angle of around 109.5 degree. So do you expect any deviation from this idealized angle? If so, why? Your time starts now.
Two minutes. Two minutes. I'm sorry. 3 minutes.
Hello, am I audible?
Yes, you're audible.
Yeah, so we are going on with the option that the typical, I mean, it will have a deviation from the typical tetrahedral angle, because we can see in the compound that that C1 is sp2 hybridized because it's a carbocation, and C2 is still sp3 hybridized, so there can be a special movement in the, I mean, position of C2. So I think we can, this is the bicyclic stuff, right? So we can assume that this part of that bicyclic, I mean, to be a hypothetical square.
So I think it will be 90 degrees. So it will be less than the typical tetrahedral angle. So that's our answer.
Okay, thanks. So that was the answer of Team E. Now we'll move over to the next question, which is meant for Team F. Team F is Shomadipto Biswas and Shagato Saha. So Team F, here is a question. A complex P, MCO5H2 changes to a complex Q, MCO5H2, where M is a metal. Assume that both the complexes exist and both the complexes are stable. You have to select the true options from among these 6. Number 1, P has molecular hydrogen, Q has a dihydride. Number 2, P has hydrogen ion species and Q has molecular hydrogen. Number 3, bonding of the hydrogen species with metal in P is best described as M-eta2H2 bond. Option 4, the metal M has been reduced in going from P to Q. Option 5, metal M has been oxidized in going from P to Q. And option 6, in P, the H2 species acts as a pi acceptor into the sigma star orbital. Your time starts now.
Two minutes.
We are ready with the answer.
Please go ahead with the answers.
So it is, I believe, we believe it is 1 and 5. So P has molecular hydrogen and Q has dihydride.
and in that process the hydrogen is reduced to hydride, and in that process the metal will be oxidized.
Okay, so only 1 and 5.
Yes.
Okay. So that was the answer of Team F. Great. So thank you for your answer. Now we are ending with the round of easy questions in the objective round. We'll now move over to the more difficult questions in this round. So buckle up your seatbelts and get ready for that. You'll be allowed 6 minutes to think and answer now. Again, with the additional 1 minute and the associated penalty of 10% of the points that you score. Also remember that in this case, you may be able to take a hint, but you'll again lose 20% of your points if you take the hint. So with this, we'll now move over to those questions. So the first question would be for Team A. So Team A is the team of Orpon and Aditya. So chiral Bronsted acid-assisted Lewis acids, that is BLAs, they're used as catalysts in a lot of asymmetric cycloaddition reactions, and they are highly efficient. So we're here trying to analyze the efficiency and the selectivity of the BLA given below in the Diels-Alder reaction. Here are 3 components of the Diels-Alder reaction, A, B, and C. A is reacting with B and A is reacting with C separately. Explain why the BLA catalyst which has been shown, it would act as a catalyst. This is the first subpart of your question. Second, account for different phase selectivities in the Diels-Alder reaction for B and C when the BLA catalyst is present. Okay, so B and C show different phase selectivities. You have to answer why. And to make your reasoning easier, you can consider the BLA catalyst structure to look as shown. Will not be providing any hints, extra hints for this question. This is all that we have to offer. So your time starts now.
Two 2.5 minutes. 5 minutes are up. You have another minute.
Hello.
Yeah, go ahead.
So there are two parts to the question. First of all, why is it that the given compound is a catalyst, and then why do B and C behave differently, have different phase selectivities, right?
Yes.
So first of all, if you see the compound this BLA, you can see that we have nitrogen and boron both connected to each other, right? Now nitrogen is a Lewis base and boron is a Lewis acid, so it will polarize the diene in a way that will in the cyclopentadiene, one of the bonds will develop delta plus charge, one of the bonds will develop delta minus charge. So the diene will basically be activated for Diels-Alder. And now for B and C, why do they have different phase selectivities? So we have read in Diels-Alder reactions that plus I groups uh, slow the reaction down when present in the dienophile, which is B and C in this case. So as for different phase selectivities, I think that in B, since due to the methyl in the uh, vinylic bond, uh, in the C double bond C bond, the delta plus delta minus pattern will be different from that in C, where the I mean the carbon connected to the carbonyl here will be slightly more delta plus, and in C it will be delta minus. So that's why there will be a different orientation of attacking the diene. So yeah.
And that accounts for the different phase selectivities?
Yes.
Okay. So that's the answer of team A. Cool. We'll move on to the next question now. So the next question will be to team B. And team B is the team of Onkon and Ritik. So you've got two canonical structures which have been shown here. One in which the metal has been coordinated face on, and the other in which there is a metal or cyclopropane sort of thing. Which of the following you have been given two compounds, K-PtCl3C2H4 and K-PtCl3C2CN4. Which of them has a greater tendency to exist in the metal or cyclopropane form? This is the first subpart. Second is compare the metal carbon bond in both the cases. Bond means the bond length. Okay. So your time starts now.
3 minutes. Six minutes are up.
Yes, so we are ready with the answer.
So go ahead with the answer. You don't have much time.
Okay, in case of C2CN4, we would see the metal cyclopropane form. This is because C2CN4 is a better pi acid than C2H4. So what's happening is that in the left structure, it's just a donor of 2 electrons, while on the right form of the structure, it's acting as a donor as well as a pi acceptor. So it's there is some donation coming from the metal center to the pi star orbitals of ethene this ethene molecule. So in case of C2CN4, this pi acid acceptance is easier because CN is causes a lot of through its conjugation, it improves the pi star. It lowers the energy of the pi star orbitals. Thus, it makes it easier for this pi acceptance to occur. And the carbon-carbon bond would be it would be more of a sp3 bond in case of C2CN4, while in C2H4, the p this the pi nature of this double bond would be retained, so it wouldn't be a sp3 bond, while in C2CN4 it's a sp3 bond.
So two things. Number one is the question talks about metal carbon bond and not about carbon carbon bond. And number two is in the first subpart, what you were saying is that in the canonical structure on the left, you're saying that there is no pi acidic character of the substituted ethylene moiety, right?
Yes, I meant the general C2X4 molecule.
Okay. So in the C2X4 molecule, in the left structure on the left, there is only a donation, sigma donation from the ligand to the metal, no pi back donation. And in this one, you're saying that there is pi back donation as well as sigma donation.
Yes.
Okay, cool. And your question, you answered about the carbon-carbon bond, but not about the metal-carbon bond. So would you like to go about that in very quickly, in maybe 1 second, just now?
At least for the right molecule, like in the metal cyclopropane form, it would be more of a MC bond would have more of a sigma characteristic than in the right case. In the left case. Sir.
Cool. I didn't get it properly, but we wanted the bond length. Anyway, cool. That's
the bond length would be shorter in the cyclopropane form.
Why?
Because there's a better overlap through pi star. Through a pi star back donation.
Okay. Thanks for your answer. So now we'll move over to the next team, Team C. So the next question, please, Anubhav. Yes, so Team C, you can see your question on the screen. Team C is that of Pravar Kataria and Dev Gupta. So M is a metalloprotein, X and Y are ligands that bind to the metal center of M. There are solutions which contain a variable ratio of M and Mx. We are defining a quantity S as Mx by that Mx plus M thing. They are treated with small amounts of Y. You've been given two reactions which take place. One is Mx reacting with Y to form M plus and XY minus. And M along with 6Y molecules, the 6Y ligands, they are forming MY6. You are given that ligand Y binds cooperatively with M. So the question is, sketch a rough plot for the ratio of MY6 formed to Y added. Sketch a rough plot of this ratio versus S, where S is the quantity as has been defined before. So you'll have to sketch a plot for this. There are some assumptions provided. Assume that S is never 1 and Y is a limiting factor even when S approaches 1. If you are making any other assumptions, feel free to do that, but get back to us with whatever assumptions you've made. So you may want for this you'll need a graph. You can share your screen if you're using a graphic tablet of sorts or whatever. If not, then you can draw and maybe show us or send it on the chat or something of that sort. And explain your solution as well. So your time starts now.
Shukri, if they want to present on the screen, then please give them the required permission.
Yeah. So if you're wanting to present on the screen at the end of that time, please inform us. We'll give you the permission to present.
Please be aware that the 6 minute time, the 6 plus 1 minute time is for thinking and answering both.
Three minutes.
Yeah, we would like a hint in this question.
So unless and until a question displays a question mark, the hint is not available. So in this question, we do not have a hint.
Oh, okay. My teammate wants to explain, but his mic is not working, unfortunately.
Then could your teammate could he send a solution to you or something of that sort? I don't know. How else can we make it work?
Uh, uh, can you please give the permission to share the screen? He wants to share the screen.
Oh, yes, sure. So could you please tell me what's the name? Dave, right?
Yeah,
Which
Dr.
account? Okay, cool. Yeah, I'll give him the permission. Make a presenter. Change. Yeah, we've made him a presenter. Go ahead.
6 minutes.
I think we can give them one more minute due to these technical.
Yeah, sure.
Yeah. So go ahead. I've given you the required permissions. You can share screen.
Must I stop presenting for this?
Yeah. You should stop presenting on once.
Hello, is the screen being shared? Okay.
Yeah. Okay, so this is your graph. What is that 1 by S or something? 1 by 6. And could you please show the axis levels? That is S, and that is the left one is, okay, that ratio. Okay, cool. So you've plotted that ratio versus this, and this is the nature of the graph. You're saying that it approaches an asymptote at 1 over 6. Okay. And it starts. Okay, so the graph doesn't touch the y-axis, right? S never goes to 0. Is that what you mean? Now, we could see the graph. Dave, I think you can explain your solution. Could you please unmute and explain your graph? Why you think it should be that way?
I think his mic was not working.
Oh, okay. Yes, sir. That's right. No, this is difficult. Pravar, could you please explain?
Quickly.
Yes, I couldn't hear you.
He can write on chat box quickly.
Yeah, you can write on the chat box if it doesn't work. On this meeting chat, you can just type out. Or if you, okay, your microphone is not working, it's an earphone. Yeah. If you're using an earphone, you can just remove it and try whether that works.
You can try a different device if needed.
Yeah, and like if you're using an earphone, the easiest would be to first remove it and check if the problem is with the earphone.
I think he has unmuted himself.
Okay. Yes, Dave, go ahead.
Just giving a heads up, you've already exceeded 9 minutes, even though you have technical difficulties. But yeah.
Yes, please try to,
Please be quick, yeah.
Yeah.
I just want to suggest a WhatsApp call between the teammates and the answer coming through the other one's mic.
Yeah, that's something that also you could do. So Pravar, you could have a WhatsApp call with Dave and then put it on speaker.
Yeah, just a second. Yeah, he's on the call.
Yes, Dave, go ahead. So what is your rationale for the solution? We can't hear anything except some static. Is Dave saying something?
Yeah, it's very faint. Could he write the solution and post it on Teams or something?
Have you put it on speaker? So it's not working that way as well. Okay, cool. So, okay, you can...
Okay, if you send the answer within 10:20, we will accept it. 10:21, okay, we will accept it.
Yeah, just within 2 minutes, type out your solution in the chat box.
Yes.
We shall move on to the next question then.
Yeah, I think we can do that. So let's move on to the next question. Team D's question. So Team D is that of, just a second. So Team D is that of Kumar Satyam and Hardik Rajpal. So here is a question on double-stranded DNA for you. So look at the double-stranded DNA carefully. So to this, we are adding an appropriate amount of a soft metal cation. And then the proton NMR spectrum, it changes as shown. The spectrum on the left is the spectrum before the soft metal cation was added. The spectrum on the right is the spectrum after the cation has been added. With the help of the spectrum, can you tell what has happened on the addition of the soft metal cation? For your reference, you have been provided the 4 bases which are there in DNA, and the highlighted hydrogen atoms are the atoms which are available after the binding of the base to the sugar. Okay, so these are not utilized for binding to the sugar. After the binding has occurred, the hydrogens which are available have been detected. So with the help of the spectrum and with this information, can you tell what has happened? A hint is available for this question if you want to take it. Your time starts now.
Right, I'd like to avail the hint.
Okay, so hint, Anubhav, try to find a mismatch in the DNA strand. Look at the DNA strand carefully.
Okay.
Three minutes.
Right, I'd like to pass the question.
Okay, so you don't want to answer this question. Cool. So then
Yeah,
we'll move.
Could you give us a minute? He explained me on the WhatsApp. Yeah, it was not audible to my mic, I suppose. It was very faint. Could I say the solution in just under a minute if you allow?
Yeah. Go ahead.
Yeah, initially when S equal to 6, the concentration of Mx is tending to 0 in comparison is much less than the concentration of M. So majorly the reaction the reaction when S is tending to 0. So yeah, the concentration of Mx is very low. So the reaction 2 takes place majorly because concentration of M is very high. So so majorly M by 6 is formed, which is 1 by 6, which is almost 1 by 6 the ratio of Y added. But when S tends to 1, the concentration of mx is much greater than concentration of m, so the mx6 formed is much less in comparison to y added because much of the y is consumed is in the reaction 1. So the graph would look like okay, I'll just could I switch on
No,
my
the graph he has shown the graph.
Okay, so yeah.
Okay, so the justification for the graph is this. Okay, cool.
Yeah.
Thanks.
Thank you.
So team D has pass this. Move over to Team E. So, Team E, your question is on gold nanoparticles. So, gold nanoparticles are functionally modified by adding thiol white to their surfaces. Why is a there are three terminal groups. They are exposed to the surfaces, and they are what? Number one is polyethylene glycol. Number two is azide, or they can be alkyne. Now, polyethylene glycol is common to all gold nanoparticles. Some have azides and others have alkynes. This has been represented using these two figures, where you can see the terminal group Y, whether it is PEG or it is alkyne or azide, and they have been given different representations. And these, the ratio of PEG to azide or PEG to alkyne on a gold nanoparticle is about 5:1. These modified gold nanoparticles are suspended in an alkaline solution having some cupric ions. The solution is now red. Now we are externally adding a protein which reduces the copper ions from their +2 state to +1 state. The solution now turns violet. Why? Your time starts now. A hint is available for this question as well. So your time starts now. And this is a question to Team E. Shayantan and Shubhajit. Over to Team F. Team F is that of Shomodipto Bishash and Shagato Shaha. So Team F, you've been given a reactant here, and then you're treating that with an acid and also with another aromatic compound, disubstituted, 1,3-disubstituted compound. And you're getting this. The initial reactant, which has been shown, is present as a mixture of diastereomers. Upon completion of the reaction, you're observing a 95:5 diastereomeric ratio. That means this reaction is showing great diastereoselectivity. You have to predict the major diastereomer for the reaction and also account for the selectivity of the reaction. I hope the question is clear. There is a hint available for this question. So your time starts now.
Could we get the hint?
Sure. So the hint is think about conformational analysis. There's a question on conformational analysis.
Three minutes.
Am I audible?
Yes, you are. Go
Yes,
ahead,
you are.
please.
Yes.
Yes, so it will undergo electrophilic aromatic substitution at the hydroxyl position. And since there is steric hindrance caused below the plane by the methyl group and the tertiary butyl group, it will move above the plane.
What will it undergo? Electrophilic aromatic substitution at the hydroxyl, that carbon.
Yes, so as in a cation will be formed there and it will attach to the other phenyl moiety.
Okay, yeah, cool. Okay, so your answer is that it will be above the plane. So the anti-diastereomer is the major product according to you.
Yes, and my partner has something to say here.
Yeah, go ahead.
It will be more of a Gauss configuration as it cannot form the eclipsed one, so it would be more of a Gauss.
You mean conformationally?
Yeah.
the conformation of the product, you feel that it will be more like gauche. And the anti-diastereomer is the major product according to you.
Yes.
Okay, cool. Thanks for the answer. So we have covered all the rounds, all the questions in this round for all the teams. Now, one of the questions was not answered, which is the question on DNA. I don't exactly remember the question number. So we can have this question up for the grabs. We would be sending out, like you can attempt this question right now. You would get 6 minutes plus 1 minute, or no, not 6 minutes. Let's keep it at 5 minutes. So you get 5 minutes plus 1 minute to think and answer completely. You will, if you are correct, you get half the points, which is essentially about 7 or 8. And if you're wrong, then you get a negative marking of 2. So you've already been provided with the hint. So your time starts now. Anyone can choose to answer, any of the teams.
Please unmute and state your team name when you do.
Yeah.
If no one begins to answer by 10:44, we shall just skip it.
Hello, am I audible?
Yes, you are.
So we have an answer in this regard. Our answer is that.
Which team are you from?
Team F.
Okay.
So our answer is there is a thymine hydrogen bond. So our answer is when the soft metal ion is added, the NH bond it would coordinate with the soft metal ion, and we see a spectrum near the 11 ppm, and that would be. And there is no spectrum in the final spectrum, so the NH that was present, which is giving the spectrum near 11, that would be absent in the final spectrum, where the soft metal ion will coordinate with the nitrogen one, which is giving the spectrum at 11 ppm.
Okay, great. Thanks for your answer. So with that,
judges, please note that they were from Team F, the ones who answered this question.
The answer was from Team F, and the one who, so in this round, if they have answered correctly, they get 8 points. If they have not, then 2 points shall be deducted from their score. So with that, we come to the end of this session. The subjective questions, the next round will be the subjective round. The questions that shall be released to you. Was this question covered? Yeah, this question was covered, yes. So the questions will be released on the general channel of this team at 11 a.m. The points for each question are mentioned in the question paper itself. Teams may choose to attempt and solve any number of questions and upload a .pptx, .docs or PDF file with solutions to these questions by 1:15. No submissions will be accepted after 1:15. You cannot make any edits to the document after 1:15. From 1:15 p.m. we'll begin the presentation round for this session, for the subjective questions. Whether you're making any edits or not shall be monitored by a dedicated team of volunteers. Any attempt to edit those will be met with strict penalties, not excluding disqualification. So you can have a break for a few minutes and then we'll release it at 11 and we'll reconvene at 1:15 p.m. Hope you enjoyed the first session. Thanks.
Please note that you can upload a PPT file or a doc file or a PDF file, but it should be presentable to the judges. Also, please note that these 3 subjective type questions, you can answer as many as you like. I would recommend personally that you go for 1 or 2 questions maximum.